Okay, we start chapter 3, quadratic functions and equations, inequalities. We do not do the inequalities, we just do the quadratic functions and equations. We didn't do section 3.1, okay? Please do not even read section 3.1. Section 3.2, quadratic equations, functions, zeros, and models. Okay, we've done zeros, we've actually done the equations in R.5. The models is, of course, word problems. So quadratic equations and functions. Some of the ideas and procedures in this chapter were done in section R.4, that was the factoring chapter, and R.5, that was the equation solving chapter section. So R.4 was factoring and R.5 was equations. And we want to review those sections, especially if you're rusty on your factoring. So as also the general concepts for functions that were developed in chapter 1 apply to quadratic functions of this chapter. Remember, after all, these are functions. General forms. Number 1, the general form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are numbers. Ideally, we like them to be integers with a not equal to 0. It's having an x squared term that makes it quadratic. Now notice that if we look at degrees, it's also a second degree equation. So second degree equations, quadratic equations, they're the same thing. The general form of a quadratic function is f of x equal ax squared plus bx plus c, where a, b, and c are numbers, again ideally integers, with a not equal to 0. Again, you must have an x squared in order to make it quadratic. Notice the similarities. The function is an f of x equals, and the equation is set equal to 0. And also notice in the equation, the powers of x are decreasing. The squared term, the x, the constant. That is the way we like to have it. Remember, without the equal 0 part, that was one of our factoring techniques back in section R.4. Number 2, recall the following facts about functions in general. The zeros of a function are numbers which, when plugged into the function, make the function equal to 0. Remember, zeros are numbers. So for a quadratic function, to find the zeros, we will need to solve the quadratic equation, ax squared plus bx plus c equals 0. We've actually already done that. Okay, we've actually solved equations that had an x squared with them. The x-intercepts of a function are found by solving f of x equals 0. So in the case of a quadratic function, we'll again have to solve the quadratic equation, ax squared plus bx plus c equals 0. Remember, to find the zeros, to find the x-intercepts, is the same procedure, no matter what the function is. The difference is the zeros are numbers, x-intercepts are points. Number 3, the y-intercept of a function is found by evaluating f of 0. Remember, that's for any function. You evaluate f of 0. So for a quadratic function, you're also going to evaluate f of 0. For each of the following, we're going to find in part A the zeros, part B the x-intercepts, you express your answers as points, and for C the y-intercept, express your answer as a point. Okay, now for a quadratic function, there does not have to be any x-intercepts, which means that there would be no zeros. There has to be a y-intercept. Every quadratic function does have a y-intercept. Here's our first one. F of x equals x squared minus 7x minus 8. Remember, in part A, we're looking for the zeros. So to find the zeros, we're going to solve x squared minus 7x minus 8 equals 0. Okay, we've got a factor. I want numbers that multiply to be minus 8 and add up to be minus 7. It's got to be minus 8 and 1. So x minus 8 times x plus 1 equals 0. And then you would set each factor equal to 0. So I get 8 or negative 1. Okay, the 8 comes from setting x minus 8 equals 0, and the negative 1 came from x plus 1 equals 0. Okay, don't put them in parentheses. The zeros are numbers. Okay, for part B, the x-intercepts. Okay, using what I found from part A, the intercepts as points, just put those as points. So I'd have 8, 0, negative 1, 0. Remember, the y-coordinate of any x-intercept is 0. Part C, I wanted you to find the y-intercept. Remember, for a y-intercept, evaluate f of 0. So 0 squared minus 7 times 0 minus 8, you end up with minus 8. As a point, we write 0, negative 8. Notice if we were to graph it, we actually have 3 points now. Number 2, g of x is 2x squared plus x minus 3. Okay, for part A, the zeros, you're going to solve 2x squared plus x minus 3 equals 0. Okay, we've got to factor it. We're going to go through the agony of splitting the middle term, just to remind you. So a times c is 2 times negative 3. I get negative 6. So I want numbers whose product is negative 6 and whose sum is positive 1. So we can make a little list, but it's 3 and negative 2. So to split the middle term, I've got 2x squared plus x minus 3 is 2x squared minus 2x plus 3x minus 3. Okay, put the 2's together, the 3's together. Now I do my grouping. From the first two I factor out 2x. From the last two I factored out 3. So I have x minus 1 times 2x plus 3. So we have it factored. Now again, if you saw how to factor it, hopefully you would not go through all this. You would just factor. So I've got x minus 1 times 2x plus 3 equals 0. And then you're going to set each factor equal to 0. I get the 1 from x minus 1. I get negative 3 halves from 2x plus 3 equals 0. Remember, you subtract 3 and then divide by 2. So those are my two zeros, 1 and negative 3 halves. If I want to get the x-intercepts, remember, those zeros are going to be the x-coordinates of the x-intercepts. So from part A, I get 1, 0, negative 3 halves, 0. For part C, the y-intercept, we're going to evaluate g of 0. So 2 times 0 squared plus 0 minus 3, we get negative 3. As a point, 0, negative 3. Again, most of that we've actually already done before. The square root principle. Okay, again, we first saw this way back in section R.5. Remember, it said let capital X be a variable expression and let capital A be a non-negative real number. So remember, non-negative includes 0. If capital X squared is equal to A, then we can take square roots of both sides to get the square root of X, to get X is equal to plus or minus the square root of A. Okay, remember, you have to physically remember to put the plus or minus. So beware that there are two numbers, the negative square root of A and the positive square root of A. Okay, again, we did this back in section R.5, and now that we've completed all of chapter 4, we would know how to simplify our square roots. Like if you had the square root of 8, 8 is 4 times 2, and the square root of 4 would be 2, so you'd have 2 square root of 2. Again, don't forget there are two numbers. You have to remember to put the plus or the minus. That is the usual thing that goes wrong. Let's try some examples. Solve for x, simplify your answers, do not use mixed numbers and decimals in your answers. Do not approximate. Now, what we're about to do should remind you of what we did way back in section R.5. Number 1, I have x squared equals 7. Okay, you have something squared equals a number. You're going to take square roots. Square root of x squared equals square root of 7. The left-hand side becomes x, and on the right-hand side you have to put plus or minus square root of 7. Now, if you want to separate them, x equals negative square root of 7, comma, square root of 7. Now again, when you're in my math lab, be sure when you put the comma here, be sure you are not under the radical. If you're under the radical, I'll mark it wrong. Commas do not go under square roots. They go outside the square roots. Number 2, I've got 3x squared equals 15. Okay, except for the 3 in front of the x squared, it does look like number 1, so first we're going to divide by 3. So I'll have x squared equals 5. Now it is just like number 1. Take square roots. Square root of x squared equals square root of 5. Left-hand side becomes x. Right-hand side becomes plus or minus square root of 5. And again, if you separate them, you'd have negative square root of 5, comma, positive square root of 5. Number 3, I've got x plus 9 squared equals 13. Okay, you have something squared equals a number. Take square roots. So I have the square root of x plus 9 squared equals square root of 13. The left-hand side becomes x plus 9. The right-hand side becomes plus or minus square root of 13. Then you're going to subtract 9. When you put the minus 9, put it before the plus or minus square root of 13. Don't put it after. Put it before. You should learn how to write correct mathematics while you're in the class. So x is going to equal negative 9 plus or minus the square root of 13. And there it is if you separate into two numbers. Negative 9 minus square root of 13, negative 9 plus the square root of 13. Again, part of what you should be learning is how to write mathematics correctly. And the number negative 9 does go before the plus or minus square root of 13, not after. Just like when you take an English class, you're learning how to write English correctly and speak it correctly. In a math class, you should learn how to write mathematics correctly. Number 4. I have 4 times x minus 2 squared equals 32. Okay, the first thing we need to do is divide by 4, because I want something squared equals a number. So we divide both sides by 4. That gives me x minus 2 squared equals 8. We now take square roots. I have the square root of x minus 2 squared equals the square root of 8. The left-hand side becomes x minus 2. The right-hand side becomes plus or minus square root of 8. Okay, now, while we're doing it, we're going to go ahead and simplify the square root of 8. It's 4 times 2, and the square root of 4 is 2. So this will become plus or minus 2 square root of 2. And then I need to add this 2. And it will go before the plus or minus 2 square root of 2. Again, learn to write mathematics correctly. So this is going to be x equals 2 plus or minus 2 square root of 2. And don't factor it. And if you wanted to separate it, you'd have the one with the plus, the one with the minus. Okay, standard form and completing the square. Because if you go back to this one, since it was the ultimate, this is the one that's set up for the square root principle. Okay, something squared is a number. So I want to make it look like that if I can. So the general form of a quadratic equation is ax squared plus bx plus c equals 0. Okay, that was the general form. It's the standard form that's set up for square root. Okay, the standard form of a quadratic equation is a times x minus h squared equals k. Okay, that's the standard form. And notice, it is set up for you to do the square root principle. You divide by a and then take square roots. So general form wants you to factor. Standard form wants you to use the square root principle. Okay, and by the way, it's always h and k, and it's always x minus h, not plus. Kind of like with the circle, x minus h squared plus y minus k squared. So notice it is standard form that allows us to use the square root principle. Okay, otherwise we've got to try to factor. Now if you want to go from standard form to general form, you just square that out, distribute the a, and subtract the k. So we want to go from general form to standard form. How do we do that? Because again, remember, standard form is what lets you use the square root principle, which is a lot easier than factoring. So to go from general form to standard form, a process called completing the square is used. So it's completing the square that lets us go from general form to standard form. We will illustrate the process. Okay, the important part for you is what comes out of completing the square. I will never make you solve an equation by completing the square. Okay, the book might, someone else might, even my math lab might. Okay, in my math lab, after you write down the answer, it doesn't know how you got it. So I will never make you solve an equation by completing the square. So I'm not going to hold you responsible for completing the square. I will never even ask you what are the steps for completing the square. I just want you to know what comes out of it. So the process of completing the square. Now again, I'm not going to hold you responsible for it. Okay? But if someone ever asks you, have you seen it, you can say, yes, I saw it. So we start with ax squared plus bx plus c equals 0. Now again, I'm not holding you responsible for the process. I'm not going to test you over it. I'm not going to quiz you over it. It's not going to appear on homework. Step 1. Get coefficient 1 on x squared. This is done by dividing by a. Notice, this kind of violates what we do in solving equations. Our first step is to clear fractions. Notice this first step is to create fractions. So I'm going to divide everybody by a. I'm going to have x squared plus b over ax plus c over a equals 0. Okay, notice I got fractions right away. We don't like this. Again, remember, I'm not holding you responsible for this. So you're saying, what does that really mean? It means you don't have to write it down if you don't want to. Step 2, subtract c over a from both sides. So I'm going to have x squared plus b over ax is equal to negative c over a. Now obviously steps 1 and 2 can be reversed, but no matter which order you do steps 1 and 2, you're going to be left off here. Steps 1 and 2 are not difficult. It's step 3 where all the work is. Okay, step 3 has 3 sub-steps. So part A of step 3, take half the coefficient of x. Okay, the coefficient of x is b over a. Take half means divide it by 2 or multiply it by 1/2. You're going to end up with b over 2a. That's 1/2 times b over a. Step 3b, square the above result. So you're going to have b over 2a squared. If you want to take it further, it's b squared over 4a squared. And then step C, add the above result to both sides. Okay, we're going to add it to both sides of where we left off. Remember, you're allowed to add the same thing you want to both sides of the equation. The real question is it useful? Believe it or not, adding b over 2a squared is going to be useful. So again, we left off here at step 2. We're now going to add this to both sides of where we left off. Okay, step 3 is usually stated like this. Take half the coefficient of x, square it, and add it. So again, this is step 3, and now I've added that b over 2a squared to both sides. I've put it on the end on the left, I've put it in the front on the right. Okay, step 4, factor the left side and do the arithmetic on the right side. What we have done is we have made the left-hand side a perfect square. Remember, to factor a perfect square, the way it factors is the square root of the first term, the sine of the middle, the square root of the last term. Okay, for this one, I start squaring the b over 2a. That gives me b squared over 4a squared. So there, I factored the left-hand side. Remember, square root of the first, sine of the middle, for the last. Okay, I need a common denominator here on the right. The common denominator is 4a squared. You clearly need the 4, and remember for a squared and a, the LCD takes the larger exponent. So I'm going to have x plus b over 2a squared is equal to b squared over 4a squared. And again, this becomes, I'm going to multiply the top and the bottom by 4a, so minus 4ac over 4a squared. Notice without the 4ac, you have the first, and this minus sign is this minus sign. Without the b squared, 4ac over 4a squared does simplify to just the c. Okay, I now have something squared as a number. Okay, I now have something squared as a number. And by the way, this is where the completing the square stops. I can now do the square root principle. So again, this was the end of step 4. Okay, step 5, take square roots. Square root of x plus b over 2a squared equals square root of b squared minus 4ac all over 4a squared. Okay, the left-hand side just becomes x plus b over 2a. The right-hand side, you have to remember to put the plus or the minus, and in the denominator, 4 and a squared are perfect squares. So my denominator will become just 2a. So I'm going to have x plus b over 2a is equal to plus or minus square root of b squared minus 4ac all over 2a. And to solve for x, I just need to subtract b over 2a. And notice they already have the same denominator. We didn't make this happen. We just put letters. It happened all by itself. Okay, again, remember, this is written before the plus or minus, not after. Again, learn to write correct mathematics. So solve for x. So I'm going to subtract the b over 2a, and the minus b goes in front. So I get x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All of it is over 2a. Okay, not just the square root part, all of it. Okay, some of you may recognize this thing. Okay, some of you may actually recognize this. That's what you need to remember, what comes out. This is actually going to solve the quadratic equation. So, those of you that know what it is, the above result, okay, namely this, you know what came out. The above result is so important that it has a name. Okay, remember, the process was completing the square. So the result is what's going to lead to this, the quadratic formula. So remember, you're given the quadratic equation, ax squared plus bx plus c equals 0. You're given general form. It is solved by the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Remember, the quadratic formula solves the quadratic equation, not the other way around. This is the formula. This is the equation. You have to identify the a, b, c. Remember, a is in front of x squared, b is in front of the x, c is the constant. So the quadratic equation must be given to you in general form so you can read off the a, b, and c. The quadratic formula always works. It will always solve the equation, even if the original equation would have factored. Because if it factors and you don't see it, the quadratic formula takes a little bit longer. So when solving a quadratic equation, if you don't see how to factor it in 5 seconds, literally 5 seconds, go to the quadratic formula. So when you're doing the problems on homework or in D2L or in my math lab and it says solve by completing the square, you don't have to. Solve it any way you like. Okay, if it says solve by the quadratic formula and you see how to factor it, go ahead and factor it. Because remember, what's important is, do you get the solutions right? So the quadratic formula always works, even if the equation would have factored. So some students, they always just say, I'm just going to do the quadratic formula. It always works. Okay, that's fine. It always works. The exception is, if you have x squared equals a number, then use the square root principle. Okay, if you have x squared equals a number, the square root principle actually is faster. But for some reason, most students never notice they have x squared equals a number, and they forget all about the square root principle. They'll go to the quadratic formula. They'll square it out and put it in general form. So remember, the quadratic formula requires that your quadratic equation be in general form. Let's try some examples. So solve for x, simplify your answers, do not use mixed numbers or decimals in your answers, do not approximate your answers. So here's our first one. I've got x squared minus x minus 3 equals 0. Okay, it doesn't factor. Okay, there are no numbers that multiply to be minus 3 and add to be minus 1. You've got to go to the quadratic formula. Okay, first of all, be sure it's in general form. It is. So my a is 1. There's the quadratic formula. That's what we're using. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, my a is 1, my b is negative 1, my c is negative 3. Okay, here it goes. A, b, c. Now just plug in the numbers. So I've got negative negative 1 plus or minus square root of negative 1 squared minus 4 times 1 times negative 3 all over 2 times 1. And please write the quadratic formula this way. don't put the minus b on the end. Learn how to write correct mathematics. So I have x is equal to 1 when I start doing the number crunching. Plus or minus 1, plus or minus square root of 1 plus 12. Okay, do the 1 plus 12. So I've got 1 plus or minus square root of 13 over 2. Those are the solutions. And there they are separated into the two answers. Now again, when you put the comma in my math lab in D2L, be sure you are not still in the numerator, and be sure that you're not under the square root. You don't put commas in numerators, you don't put commas under square roots. The comma belongs between the two answers. Number 2, I've got x squared minus 5x plus 2 equals 0. Okay, it doesn't factor. There are no numbers that multiply to be 2 and add up to be negative 5, since 2 is just 1 times 2. So, quadratic formula, which remember that's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And again, don't put the minus b after the square root. It goes before. And don't factor your answers. Identify the players. A is 1, b is negative 5, and c is 2. Plug in the numbers. So x will be negative negative 5 plus or minus square root of negative 5 squared minus 4 times 1 times 2 all over 2 times 1. Okay, start doing the arithmetic. My denominator is just 2. 5 plus or minus square root of 25 minus 8. Okay, 25 minus 8 is going to be 13. So 5 plus or minus, 17, I'm sorry, bad arithmetic. 5 plus or minus square root of 17 all over 2. Again, be sure that it's clear that 5 plus or minus square root of 17 is all over 2. And there it is separated. Again, be sure you put the comma between the two fractions, not in the numerator of this one and not under the square root of this one. The comma goes between the two answers, not in the numerator, not under a square root. Let's try another. I've got 5x squared minus 5x minus 1 equals 0. Okay, it doesn't factor. It doesn't. So, got to use quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, the ABC, a is 5, b is negative 5, c is negative 1. Plug them into the formula and see what happens. So x will equal negative negative 5 plus or minus square root of negative 5 squared minus 4 times 5 times negative 1 all over 2 times 5. My denominator becomes 10. This just becomes 5. So I have 5 plus or minus square root of 25 plus 20 all over 10. I can do 25 plus 20 under the square root and have 5 plus or minus square root of 45 over 10. Okay, you can't cancel the 5 over 10. Remember, in order to cancel, all plus and minus signs must be inside parentheses, and I have both a plus and a minus sign outside parentheses. However, you can simplify the square root of 45. 45 is 9 times 5. And the square root of 9 is 3. So I have 5 plus or minus 3 square root of 5 over 10. And again, don't cancel the 5 and the 10. In order to cancel, you must have factored, and we didn't factor. So plus or minus outside parentheses is stopping you from canceling the 5 and the 10. Okay, the discriminant and the nature of solutions. Anytime there's a formula to solve some type of equation, there is a discriminant. So we know how to solve all quadratic equations. We do. Whether you believe it or not, you do. First thing, try to factor. If it does not factor, or if we don't know how to factor in 5 seconds, use the quadratic formula. Remember, the quadratic formula always works. No exceptions. Now, the one time you wouldn't use the quadratic formula, even though it's, by the way, it still will work, provided you put it in general form, is if it is in the form something squared is a number, use the square root principle. That would be faster, because if something squared is a number, you'd have to square it out, set it equal to 0, and then try to use the quadratic formula. Whereas if you have square root, you're done fairly fast. So, the discriminant. What is it exactly? Definition. The discriminant of the quadratic equation ax squared plus bx plus c equals 0 is, I'm calling it capital D as in discriminant. It's b squared minus 4ac. That's the discriminant. Notice to get the discriminant, you have to have general form again. Okay, the b squared minus 4ac. Notice, the discriminant is the expression under the square root in the quadratic formula. So the discriminant is just whatever is under the radical in the quadratic formula. The part that's not under the radical, the negative b over 2a, we'll discover what it's used for later. It does have a use. It doesn't have a name, but it does have a use. Some example. Find the value of the discriminant of each of the following quadratic equations. Simplify your answers. Okay, now you're just looking for the discriminant. You're not trying to solve the equation. Here's our first one. I've got 3x squared minus 7x plus 2 equals 0. Okay, you got to make sure it's in general form. It is. So my a is 3, my b is negative 7, my c is 2. Remember the discriminant? That's b squared minus 4ac. Okay, plug in the numbers. I've got negative 7 squared minus 4 times 3 times 2. I get 49 minus 24. It's 25. Okay, the discriminant is 25. The discriminant is just a number. Okay, it's just a number. Again, you're not solving the equation. You're just looking for the discriminant. Number 2. I've got negative x squared plus 7x minus 4 equals 0. Okay, it is in general form. So my a is negative 1, my b is 7, and my c is equal to negative 4. Remember the discriminant? It's b squared minus 4ac. Plug in the numbers. I've got 7 squared minus 4 times negative 1 times negative 4. I get 49 minus 16. 33. The discriminant is 33. Okay, so the discriminant, it's not too hard to find. Now, because it is the expression of the radical, there are some people that say when you're using the quadratic formula, you must first find the discriminant. You don't have to do it first, but you do have to do it sooner or later. Nature of solutions. Okay, definition. By nature of solutions of an equation, okay, any equation, not just quadratic, we mean the following. Number 1. How many solutions does the equation have? You know, like 12, 13, 1, 0. Number 2, how many of the solutions are real? Okay, that's what we mean by nature of solutions. How many do you have, and how many are real? The connection between discriminant and nature of solutions. Okay, there had to be a connection, otherwise why are we doing them together? So the connection between discriminant and nature of solutions. Okay, now the discriminant tells us the nature of the solutions of a quadratic equation. Okay, it does. And remember, the discriminant is the expression under the radical in the quadratic formula. So we're going to show the relationship in a chart. Okay, now again, remember, the discriminant is the expression under the square root in the quadratic formula. Okay, we do not take square roots of negative numbers to give us real answers. So the discriminant could be either positive, negative, or 0. Okay, so here's going to be our little chart. The discriminant, you know, positive, negative, or 0, and the nature of solutions. Okay, first of all, if it's positive, like it's 17, we can take the square root of a positive number. It's going to be a real number. So I'm going to have negative b plus or minus a real number. So I have 2 distinct real solutions. The distinct means they're different. Suppose the discriminant is 0. Okay, the square root of 0 is 0. So my numerator of the quadratic form would be negative b plus or minus 0, which is just negative b. You get 1 real solution. Okay, now suppose the discriminant is negative. Okay, the square root of a negative number isn't real. It's imaginary. So you would have 0 real solutions, or some people will say 2 imaginary solutions. Okay, the imaginary is also complex. We're going to worry about the 0 solution, 0 real solutions. We always look for 0 solutions. So real solutions. So if the discriminant is positive, you have 2 real. If it's 0, you have 1 real. If it's negative, you have 0 real. Let's try some examples. How many real solutions does each quadratic equation have? Now note, do not find the solutions, just state how many solutions the equation has. Okay, how many real solutions it has. We're going to have either 2, 1, or 0. Here's our first one. I've got x squared plus 7x plus 9 equals 0. Now again, don't solve it. Calculate the discriminant. So we calculate the discriminant. It is in the correct form, right? So remember the discriminant, b squared minus 4ac. Our a is 1, our b is 7, our c is 9. So I'm going to have 7 squared minus 4 times 1 times 9. I have 49 minus 36, which is 13. It's positive. The discriminant is positive. A positive discriminant means 2 real solutions. Okay, 2 distinct real solutions. You can leave out the word distinct if you want. Most people, when they say 2, they mean 2 different. Okay, number 2. I've got 3x squared minus x plus 10 equals 0. Okay, again, it is in correct form. So I'm going to calculate the discriminant. Remember, that's b squared minus 4ac. See, my a is 3, my b is negative 1, my c is 10. We plug them into the discriminant formula. I'm going to have negative 1 squared minus 4 times 3 times 10. I get 1 minus 120. which is equal to negative 119. Okay, the discriminant is negative. A negative discriminant means you have 0 real solutions. Remember, you're supposed to tell me how many real solutions we have. So we have 0 real solutions for a negative discriminant. For number 3, I've got 4x squared minus 20x plus 25 equals 0. Again, don't solve it. We're looking for the discriminant. Remember, that's b squared minus 4ac. It is in correct form. A is 4, b is negative 20, c is 25. Plug them into the formula and see what happens. So my discriminant is going to equal negative 20 squared minus 4 times 25. Okay, negative 20 squared is 400. Okay, 4 times 4 is 16, and 16 times 25 is also 400. So I've got 400 minus 400, I get 0. My discriminant is 0. Okay, when the discriminant is 0, that means 1 real solution. Okay. Number 4. The equation has discriminant the square root of 67. Okay, you don't need to crunch it out. It's given to you, the square root of 67. Remember, by the definition of a principal root, the square root of 67 is positive. So the discriminant is positive. That means 2 real solutions. Remember, the square root of 67 is positive. Definition of the principal root. That symbol is the principal root. Okay, this next group of examples, I've actually called them K problems because the unknown is actually K, not X. So, again, I've usually referred to these as K problems. We'll see another type of K problem in Chapter 4. Okay, the reason I want you to know what I call my problems is that when I give you a list of the types of problems on the final exam, when you see K problems, you say, oh, these guys. So, number 1, for what values of K will x squared plus 5x plus k equal 0 have 2 distinct real solutions? So I want x squared plus 5x plus k equals 0 to have 2 distinct real solutions. Remember, 2 distinct real, I need the discriminant greater than 0. Remember, that's what positive is. I need it greater than 0. If I identify the players here, A is 1, B is 5, and C is k. So b squared minus 4ac greater than 0 becomes, okay, 5 squared minus 4 times 1 times k greater than 0. We're solving an inequality. Notice we're going to get a bunch of values of k that will work. So 5 squared is 25. So I've got 25 minus 4k greater than 0. Subtract 25 from both sides. Negative 4k greater than negative 25. Now remember, with an inequality, when you divide or multiply by a negative number, you reverse the direction of the inequality. So I'm going to get k is less than 25 over 4. So notice, a bunch of values of k will work. Again, I could have put the k anywhere, and I could have asked 2 distinct real, 1 real, or 0 real. For number 2, I have, for what values of k will 3x squared plus kx plus 6 equals 0 have exactly 1 real solution? So in this one, I want 3x squared plus kx plus 6 equals 0 to have 1 real solution. Remember, 1 real solution means the discriminant equals 0. So I need the b squared minus 4ac to equal 0. Okay, to identify the ABC, a is 3, b is k, c is 6. Okay, plug them in and see what happens. I'm going to have k squared minus 4 times 3 times 6 equals 0. Okay, 4 times 3 is 12, 6 times 12 is 72. So I've got k squared minus 72 equals 0. Notice I can make this look like something squared equals a number by simply moving the 72 to the other side. So I've got k squared equals 72. Do your square roots. Don't forget the plus or minus. 36 times 2 will give me the 72. And 36 is a perfect square, so I've got plus or minus 6 square root of 2. So there's my k problems. Let's look at some nasty word problems. Oh, I got one more, I forgot. For what values of k will kx squared minus 4x minus 3 equals 0 have 0 real solutions? So I've moved my k all the way to the front now. So I want kx squared minus 4x minus 3 equals 0 to have 0 real solutions. So I need the discriminant, b squared minus 4ac, to be negative. I need it less than 0. So to identify the players, a is k, b is negative 4, c is negative 3. plug them in, I get negative 6, I get negative 4 squared minus 4 times k times negative 3 is less than 0. So let's see, 16, see, minus 4 times minus 3 is 12. So 16 plus 12k less than 0. Subtract 16. 12k is less than negative 16. Okay, I'm dividing by positive 12, so I'm dividing by a positive number. Don't reverse inequality. So I get k is less than negative 16 over 12. Okay, that'll reduce. K is less than negative 4/3. So again, notice you get a bunch of values for k. Now, let's try some word problems. You know, these word problems are supposed to lead to quadratic equations. Just like the word problems of Chapter 1 were supposed to lead to linear, these are supposed to lead to quadratic. Now, with quadratic, you typically get two solutions. Sometimes one of the solutions won't make sense for the problem, like you can't have negative lengths, you can't have negative time, that type of stuff. So you might have to eliminate one of the solutions as a solution to the word problem. So here's our first one. The width of a rectangle is 6 feet shorter than 3 times its length. Find the dimensions if the area is 360 square feet. Okay, so back in Chapter 1, we looked at rectangle and perimeter. This time we're looking at rectangle and area. Remember, the area of a rectangle is length times width. Now, other than that, the setup is the same. Okay, the first sentence, the width of a rectangle is. So W equals 6 feet shorter than 3 times its length. So W equals 3L minus 6. So again, I'm using L and W. So the first sentence, W is equal to 3L minus 6. 6 feet shorter than 3 times its length. Okay, once you get the relationship between L and W written down, write down your area formula. Area is length times width. Fill in the numbers. Area is 360. L is I don't know. But W is 3L minus 6. Okay, it's going to be a quadratic. When I distribute the L, I'm going to have a 3L squared. So 360 is equal to 3L squared minus 6L. Remember, for a quadratic, we want it set equal to 0. Now, personally, I cannot work with negative squared terms, so I'm going to subtract 360 from both sides. I've got 0 is equal to 3L squared minus 6L minus 360. Okay, now comes the fun part, try to factor. On the right-hand side, I can factor out a 3 from everybody. Okay, now inside the parentheses, I want to multiply to be negative 120 and add up to be negative 2. Now, if you can't think of them, you can go straight to the quadratic formula. But I'm thinking 12 and 10, and the bigger has to have the sign in the middle. So it's negative 12 and positive 10. So 3 times L minus 12 times L plus 10. So I've got it factored. Now we set each factor to 0. You can ignore the 3. In fact, because it's an equation, you can divide everybody by 3. You can't set 3 equal to 0. 3 is never 0. So I'm just looking at L minus 12 and L plus 10. So L minus 12 gives me the 12. L plus 10 gives me negative 10. Okay, you can't have negative lengths. So negative 10 is no good. So L is 12. Okay, so the length is 12 feet. To get the width, go back up here. So W is going to be 3L minus 6. So 3 times 12 minus 6. 36 minus 6. It's 30. So the length is 12 feet, the width is 30 feet. Okay, please don't say 12 by 33 by 12, because when you do that, I don't know which is which. Tell me length, tell me width. And when you're doing the My Math Lab, if it says L equals W equals, don't get them mixed up. Okay, don't get them mixed up. Number 2. A 13-foot long ladder is leaning against a vertical wall. If the top of the ladder is 12 feet above the floor, how far is the base of the ladder from the wall? Okay, this is another one in which negative numbers won't make sense. You can't have a negative distance from the wall. Okay, let's try to make a picture of this. Okay, hopefully you see what's going on. I've got a ladder leaning against a wall. There, it looks like a right triangle. So the ladder is the hypotenuse. It's 13 feet long. It's 12 feet to the top of the ladder from the floor. The distance from the base is, I don't know. Call it x. Hopefully you see Pythagorean theorem, right? Leg squared plus leg squared is hypotenuse squared, right? A squared plus b squared is equal to c squared. So let's see. Square the two numbers. I got 144 plus x squared equals 169. I can make it look like x squared equals a number by simply subtracting 144. So 169 minus 144 gives me 25. I can just take square roots. Okay, the square root of 25 is going to be 5. I don't need the minus 5 because negative length doesn't make sense. So it's 5 feet. The base of the ladder is 5 feet from the wall. So anytime you got the classic ladder leaning against the wall, you now know it's going to be the Pythagorean theorem. two cars leave an intersection at the same time. One travels north, and the other travels east, traveling 7 miles per hour faster. After 1 hour, the cars are 97 miles apart. Find the speed of each car. Okay, notice since they're traveling for just 1 hour, the speed of the car in miles per hour is also how far it's gone. So I've got one going north and the other going east, but the eastbound is 7 miles per hour faster. So the northbound is, I don't know, call it x. The eastbound is 7 miles per hour faster, x plus 7. They're 97 miles apart after 1 hour. Notice it's another Pythagorean theorem. So the north is I don't know, the east is 7 miles per hour faster, and they're 97 miles apart. So Pythagorean theorem, x squared plus x plus 7 squared equals 97 squared. Okay, to square the binomial, again, to square it quickly, square the first, twice the product, square the last. Hopefully we squared enough binomials that you can do it quickly. We're going to have x squared plus 14x plus 49 equals, okay, 97 squared. I did it in the calculator and got 9,409. Okay, let's combine some terms here. X squared and x squared is two of them. So 2x squared plus 14x plus 49 equals 9,409. Okay, I want to set it equal to 0 so I can try to factor it. This is going to be fun. So I've got 2x squared plus 14x minus 9,360 is equal to 0. Okay, the numbers are all even. I can at least factor out a 2. Okay, here's a challenge for you. I want numbers that multiply by negative 4,680 and add up to be 7. Okay, if you can't think of them, I would go straight to the quadratic formula. It just turns out they're the numbers 72 and 65. Yeah, I found them right away. So now you set each factor equal to 0. Okay, don't worry about the 2. 2 cannot be made to be 0. Okay, x plus 72, I would need negative 72. X minus 65, I would need positive 65. Okay, you cannot have negative speeds. Negative 72 miles per hour north, that's no good. That actually means he's going south. So x is 65. The northbound car is 65. Okay, the other one is x plus 7. 65 plus 7, I get 72. What an amazing coincidence. So the eastbound car is 65 miles per hour. Excuse me, the northbound car is 65 miles per hour, and the eastbound car is 72 miles per hour. Again, if you did not see how to factor it, if you could not go from this step to this step with the factoring, just go straight to the quadratic formula. It doesn't take you that much longer, and you would have seen these answers, and you would have rejected the negative one. If you want to see that, let me go ahead and do that for you. So, oops, let's turn it on. Okay, so I'm going to, because the quadratic formula has that fraction, open parenthesis, so negative b, remember I'm doing it here, negative b, so negative 14. Okay, let me do the plus one, plus second square root. Okay, I'm supposed to do b squared, so 14 b squared minus 4 a c, oh my c is the big number, negative 9. No, not negative. I'm down here, aren't I? No, I'm doing that one. Oh, let me start again. Crap. Open the parenthesis. Let me do this one. That's what I'm doing. So negative 7. I'm still doing the plus one. Second square root b squared minus 4a c. That's a negative 4680. Close for my c. Close for the radical. Remember that calculator opened up this one for me. Close for the numerator. Divided by 2 times 1, just to be painful. Close that. I got the 65. Okay, now you're saying, God, I don't want to key all that in again. Okay, on the graphing calculators, on the TI-8384, I'm just wanting to edit it. I just want to change that to a minus. If you want to edit something that's already there, just do second enter. I can now edit. So let me back up. Go up here. I want that to be a minus, so I can get the minus one. So put minus. Press enter. And there's a negative 72. Okay? Oh, and by the way, you could have done it here as well. Before you factored out the 2, you could have done it right there. Okay, number 4. Okay, I've always called this the rocket scientist problem. We will see other rocket scientist problems in section 3.3. So this is the first of the rocket scientist. So the height in feet of a projectile, t seconds after being thrown in the air, is given by s of t equals negative 16 squared, negative 16t squared plus 96t plus 48. How many seconds after being thrown in the air will the projectile strike the ground? Approximate your final answer to the nearest hundredth of a second. Okay, hundredth is 2 places. Negative time doesn't make sense. So this is the height in feet above the ground. If I'm striking the ground, this has to equal 0. Now, in case you're wondering, what do the numbers mean? Okay, the negative 16, that's half the acceleration due to gravity in the English system. The 96 that's in front of the t, that's the speed that we threw the object up in feet per second. So we're throwing it at about 96 feet per second. That's just a little over 60 miles per hour. The 48, it means you were 48 feet above the ground when you threw it. So again, to strike the ground, we need this expression equal to 0. So we need to know when s of t equals 0. So that's negative 16t squared plus 96t plus 48 equals 0. Okay, all of those numbers are divisible by negative 16, because again, I cannot think when there's a negative t squared. So I factored out my negative t. Okay, I now try to factor this. Of course it won't factor. So let's go to the quadratic formula. So I get rid of the negative 16. Just divide everybody by negative 16. Okay, since I know I'm going to the quadratic formula, let me again show this on the calculator. Take out Mr. Calculator here. Okay, clear this other one out. Okay, so let me open a parenthesis for the numerator. Well, I don't really, because my 1 times 2 is just going to be 2. So let me do it anyway, though. Negative 6, just to be very pedestrian about it. Let me do the plus 1 first. So plus, second, square root. Okay, I want b squared. So open parenthesis for the negative 6. Squared minus 4 times a times, let's see, what's my c? Negative 3. Okay, close for the radical. This time I did the times instead of the parentheses for the a and the c. So I've closed for the radical. Now let me close for the numerator. Okay, and I know my denominator divided by, okay, 2 times a is just going to be 2. So let me just go ahead and do that. I get this god-awful mess. Okay, so I want how many places? 100th? Remember, that's 2 places. So about 6.46. Okay, to do the minus 1, let me do second enter. And let me scroll up to make that a negative. So that should be minus. Okay, I get negative time. It's like you struck the ground before you threw it up. Well, that doesn't make any sense. So I'm getting 6.46 and negative 0.46 from the quadratic formula. So again, there's all the nasty work for it. So again, we reject the negative time. So about 6.46 seconds after you throw it into the air, it strikes the ground. Now, if this had been saying, instead of saying strike the ground, suppose it would say I want to be 200 feet above the ground, there might be 2 places where it does it. Once on the way up and the second time on the way down. So if it says, how many seconds after throwing the air will it be like 200 feet above the ground, you'd set this equal to 200. And if you didn't get any real answers, that says it's never going to be 200 feet above the ground. Remember, striking the ground is 0. Any other height will be given to you specifically in the problem. And again, if you get 2 times, that just means once on the way up, once on the way down. Anyway, there's one of our rocket scientist problems. We'll see the other 2 later on in the chapter. Number 5. I've always called this the swimming pool flower bed picture frame problem. This is obviously the swimming pool problem. So a swimming pool measures 20 feet by 30 feet. A sidewalk of uniform width is to be built around the pool. Okay, uniform width just means it's the same width all the way around. Okay, there's enough concrete for 216 square feet of sidewalk. How wide should the sidewalk be? Now, negative width doesn't make sense, but you could have a fraction, right? You could have like, 2.5, 2 1/4. Now, it can't be 0 because, after all, we do have some concrete. So the swimming pool is 20 by 30, and we've got enough concrete for 216 square feet of sidewalk. Okay, we're going to draw a little picture. It's our solution. We make a picture. Now, when you draw the swimming pool, leave a little bit of space here because you're going to build the sidewalk. So go ahead and draw your swimming pool. Okay, there's my swimming pool. It's 20 by 30. Okay, I've made it blue for the water. Okay, I'm going to put a sidewalk around this. And the width of the sidewalk is, I don't know. I'm going to call it X as in I don't know. So I'm putting a sidewalk around this guy. So the gray area is the sidewalk. Okay, so, and the width of the sidewalk is X all the way around. Now, if I did not tell you that I had a sidewalk around a swimming pool, hopefully you can see that I do have 2 rectangles, a small one and a big one. Also, you might say, well, that looks like a picture inside of a picture frame. Okay. The sidewalk is actually, if I cut out this hole, if I cut out the swimming pool, it would be that kind of rectangular looking donut I have left. So in words, the sidewalk is the big rectangle minus the little rectangle. That's what the sidewalk is. Okay? So now I know the little rectangle, it's the 20 by 30. It's the swimming pool. I have to figure out the dimensions of the outside rectangle. So we need to determine the dimensions of the big rectangle, okay, the kind of the gray one, okay, you know, the sidewalk. Okay, don't step on these cracks, you know, your mother's back. So the horizontal dimension, okay, the left, right. I got 30 feet just for the pool. I added x on the left, I added x on the right. We added 2 x's, so it's 30 plus 2x. Okay, because of what's going to happen later, I'm going to factor out the 2. It's 2 times x plus 15. So I also put it in correct order. Okay, in a moment I'll tell you why I'm factoring out the 2's and why sometimes you won't do it and sometimes it'll help if you do it. Okay, it's actually going to help in this one. So anyway, there's the horizontal dimension. If I do the vertical, okay, the vertical is 20 for the pool, and then I put an x on the top and an x on the bottom. So the vertical dimension of this big rectangle is 20 plus 2x. And again, I can factor out a 2, and let me put it in correct order. So I'll have 2 times x plus 10. So I've got my dimensions for the big rectangle. Okay, now that I have dimensions for the big rectangle, I can now fill in some algebra stuff into this word equation that says the sidewalk is the big rectangle minus the little rectangle. Or the sidewalk is 216 square feet. The little rectangle, that's your 30 times 20. Okay, now I just have the dimensions for the big rectangle. So it becomes 216 for the sidewalk, 2 times x plus 15 times 2 times x plus 10 minus 30 times 20. Okay, length, width, length, width. Now we've got some number crunching to do. Okay, I can do 30 times 20 and get 600. Okay, before I do my foiling, let me do the 2 times 2 to get 4. So I've got 216 is equal to 4 times x plus 15 times x plus 10 minus 600. Okay, now I can tell you the reason for factoring out the 2's. All of these numbers that are outside parentheses, 216, 4, and 600, they're divisible by 4. I can make my number smaller. Okay, this is how you can tell if a large number is divisible by 4. Let me look at the 216. Okay, for the 216, or for any large number, just look at the last 2 digits as a number in its own right. So just look at 16. Can 16 be divided by 4? Yes. Then that means the entire number can be divided by 4. So that's what that means is anything that ends in double zero can be divided by 4. So again, divisible by 4, just look at the last 2 digits. So now I'm going to divide all of the numbers outside parentheses by 4. Because again, this is kind of a big number to work with. Okay, so divide all numbers outside parentheses by 4. So it gives me 54 is equal to x plus 15 times x plus 10 minus 150. Now do FOIL. Okay, FOIL out x plus 15, x plus 10. What 54 stays the same and minus 150 stays the same. So I have 54 is equal to x squared plus 10x plus 15x plus 150 minus 150, right? First, outer, inner, last. Oh, how convenient. 150 minus 150 will be 0. So when I combine terms, on the left, excuse me, on the right, I'll have x squared plus 25x. So I have 54 is equal to x squared plus 25x. It's looking a lot better now. Okay, for a quadratic, you've got to set it equal to 0. Again, I cannot think with negative squared terms, so subtract 54. So that's going to give me 0 is equal to x squared plus 25x minus 54. Okay, again, this equation will be the last equation, excuse me, the first equation on the next line. Okay, factoring time. Now again, if you don't see how to factor it, go to the quadratic formula. Multiply by negative 54 and add up to be 25. It's going to be 27 and 2. And notice if you're making your list, that would be the second pair in the list. Set each factor equal to 0. That's negative 27. That's 2. Okay, you can't have negative 27 as a width, so we reject it. The sidewalk is 2 feet wide. Kind of a long and involved problem. Okay, the last example is the true picture frame problem. The outside of a picture frame measures 12 inches by 14 inches. If the frame is of uniform width and 99 square inches of picture shows, how wide is the frame? Notice 99 cannot be evenly divided by 4, so there's not going to be any point in factoring out 2's if I can do it. So the outside is 12 by 14, and you got 99 square inches of picture showing. You're looking for the width of the frame. Okay, let's make a picture of the problem. Okay, so we're going to make a sketch. Okay, there's the outside of the frame. It's 12 by 14. Okay, the picture that's in the picture frame is inside of here. So I've got a little rectangle in here, and it's 99 square inches. So I've got a picture of a gray box that says 99 square inches. Okay, the frame is of uniform width all the way around. Okay. Again, hopefully you see a rectangle inside of a rectangle. Okay, in this setup, the little rectangle is the picture. So the picture is equal to the little rectangle. Now I know the area of the picture, 99 square inches. I have to get the dimensions of the little rectangle, of this gray rectangle. So the horizontal dimension. It started off being 12 for the outside of the frame. Take away x on the left, take away x on the right. I'm taking away 2 x's. So it's 12 minus 2x. So this is 12 minus 2x. In the vertical, notice the vertical is going to be 14 to start with for the outside of the frame. Take away x from the top, take away x from the bottom. It's going to be 14 minus 2x. So the vertical, 14 for the frame from here to here. Take away x on the top, take away x on the bottom, take away 2 x's. So we now have the dimension of the little rectangle. And again, there's no need to factor out the 2's because 4 will not go evenly into 99. It's just not an even number at all. So now I can fill in some algebra stuff into this little innocent looking equation. Remember, the picture is 99, right? That's given in the problem, 99 square inches. So 99 is equal to 12 minus 2x times 14 minus 2x. Okay, we've got to FOIL out the right-hand side. So 99 stays the same. So first, outer, inner, last. Okay, on the right-hand side, I can combine the outer and inner, and let me also put it in correct order. So this is where we left off. Okay, 4x squared minus 52x plus 168. Okay, got a set equal to 0, so subtract 99. I got 4x squared minus 52x plus 69. Okay, I didn't even want to strain my brain. I'm just going straight to the quadratic formula. So my a is 4, my b is negative 52, my c is 69. So there it is. Okay, if I give it to my calculator, just so you can see it one more time, I guess turn it back on, huh? Clear that crap out. Okay, so open the parentheses. So, open parentheses. Okay, negative 52. That's just going to be 52. Let me do the plus one first. Plus, second, square root. Okay, let me put the minus 52 in parentheses. Negative 52 squared minus 4 times a times c. Close for the square root. Close for the numerator. Divided by, open for denominator, 2 times 4, close. Okay, I get 11.5. Okay, it is what it is, 11.5. Okay, to do one for the minus, second, enter. Go up and change the plus in front of the square root to a minus. I get 1.5. They're both positive, so there's not a clear one to reject. But anyway, I get 11.5 and 1.5, so this 11.5, remember, we're taking it away twice. The outside of the frame is only 14 by 12. Okay, so this is too big. Okay, it's not that it's negative, it's too big. So the frame is 1.5 inches wide. The other positive number is just too big. This will always happen with the true picture frame problem. You get 2 positive answers, and one of them is just going to be too big. Because remember, the value of x has to be subtracted twice, a top and a bottom, a left and a right. And if you subtract 11.5 twice, you run out of frame. That's the end of section 3.2.